All right, let's get started. Thanks for joining me today, this evening with our stream. To the Twitch viewers, I really appreciate you hanging out with me again this evening and following along with what we're doing. YouTube viewers, when the video finally drops, I really appreciate you following on with the series there and keeping up with us. It's been really fun, and we still have a long way to go with this particular series of getting this product done. So today we are going to work on assembling the resistor box. Once everything's all done and I'm satisfied with how it looks, like I said before, I'll get a bill of materials and get all that built up, a wiring diagram, and get it all put up on the GitHub. But I want to make sure it builds fine and it works fine before I do that. Pretty much every part that's going into it can be bought off of Amazon, so it's nothing huge. I'm not asking you to spend money that you can't afford, so don't, if you can't afford it, don't buy it. Don't do it. I will kind of aggregate everything and put this as part of the expense into the project. I figure I'll go and do that once I get everything assembled and know exactly what it's going to take. So the last stream, the last video, we kind of designed the 3D printed plastic parts. I got them out. I had to make some tweaks. Just a little too short. I had to extend the length and width. But now they're like perfect. So let's get over to here. And okay, so now we have all the parts. There's probably going to be a little bit of soldering here and there to tie into some of these components. But it's not a big deal. We're going to, so quick rundown of the parts. The ammeter, that's going to go into the front panel. Its wires, ignore the mess. We have our 12 volt input jack because this will run the fan as well as the electronics. For the ammeter, we're going to have we're going to follow their diagram for the independent power supply. Because that way this can run the fan and run the electronics in this sensing box without interfering with any actual measurements. Because you could do a shared power, but I don't like doing that. I don't want to do that with this since it can be independent. So we're going to be following this wiring diagram that I printed out. Here's the main attraction, the wire wound resistor, 200 watts at 50 ohms. This is what we're going to be pushing current through to draw, the power switch for the front panel. That's going to be to control everything. Our banana plugs, where we're going to basically link into it. The nice little Noctua fan, so I don't have to butcher the connector that's already on it in case I want to pull out, use it in another project or a computer or whatever. I have the connectors, the connector for it, so I can just solder onto this and just tie it in like that. That way I don't have to worry about cutting this and ruining a perfectly good fan. That makes life a little bit more simple. I got the screws, and then for the internals, I'm just using some 18 gauge hookup wire. This stuff is the silicone stuff. You can buy it off Amazon. You get those multi-packs with the different colors, so I'm just using this for the internals. It's 18 gauge, which even for all the hookups to the resistor should handle the current. 18 gauge can typically go up to 14 amps of current based on what I've researched and used in the past. We don't really intend on pushing anywhere near that, just a couple amps, so we should be fine. If it does seem to be a problem going through the load resistor, then we'll worry about it down the road, but I don't see it being a problem because the panel meter came with 18 gauge wire, so I don't see it being a problem. And then tying some of the stuff together to make it a little bit easier, I got this selection of lever locks of lever terminals. Again, pick these up off of Amazon. They'll be in the BOM. You can get a multi-pack relatively cheap. These are great for projects, so it makes it a little bit easier to reuse parts without soldering everything all together. Then I have the the black oxide screws that I want to use to tie it all together. The heat set inserts if we need them. And then to tie onto the terminals of the resistor, I'm going to just be using M4 socket head cap screws. I could probably go M5. Let me see if I've got any M5, because that would probably be better. Yeah, I do have some M5 here. I got some black oxide, that'll work. Yeah, we'll just use black oxide. All right. Fortunately, I made black oxide lock washers, but we'll just use regular lock washers. I should have ordered star washers for this project to bite into the terminals a lot more cleanly, but lock washers should at least do the trick. I'm sure a lot of you are eager to see the 3D printed plastic. So this is the back panel. So this is the panel that they're shipped, that the enclosure shipped with. And then so this is the 3D printed. This would be the back panel, power in. Your fan will get mounted to this side. And then this is the 3D printed front panel. Power switch, banana plugs, and the electronic instrument package goes here. Got to clean a little bit of the plastic off, but that's what old deburring tools for. Just kind of clean that off. Don't want to take too much plastic off. Don't want it to be too clean. All right, perfect. And the nice thing is I don't know how well you'll be able to see it on camera, but really nice snug fit into the framing, and the screw holes line up almost practically perfect. They're practically dead on alignment, so we won't have to really do any cleanup there. Just have to kind of size them up a little bit for the M3 screws to pass through properly. Not really a big deal. Yeah, I've got drill bits. We can clean them up. I'm hoping that I don't have to put the heat set inserts, because a lot of times you can just bite into the plastic and it'll just thread and it'll be fine for what it needs to do. Like I said, worst case, we'll just put the heat set inserts in and deal with it that way. So the first thing that we need to really get going is move some junk out of my way here. So this is the template that we threw together in Fusion DXF file for the hole for the central shaft, and then the hole for the indexing mark, basically. So we just need to drill the top cover, which is now buried under a bunch of junk because I still need to clean my workshop. It's just life doesn't slow down. My day job, I still have work to do there. All right. So we have the cover. I'm not even bothered with the drill press. This is such thin sheet metal. And just a drill bit and a piece of plywood for a spoiler board. So one of the things I'll do is I'll kind of haphazardly use a pair of scissors and trim this out. And try to wonder where my tape is. Wonder why my idiot self forgot to bring tape in to tape this to the top box, but hey, you know. So, oh yeah, look at that. It fits like a glove in there. So I'm not going to bother cutting that. Again, it doesn't have to be too terribly perfect. I'm not going for perfection with something like this. If I were going for perfection, I'd pay somebody else to do this for me. This is just a... And honestly, down the road, if there is a demand and people do want me to actually build these for them and sell them to them, what I'll probably do then is I'll probably design a template for drilling that I can just 3D print and just lay it down in here. And then just use that to mark my centering holes, my center holes and stuff like that with like a punch. But for a one-off, I'm not going to sit there and concern myself with how perfect it looks. Because it's just going to, oh, I don't even have to tape it. It's just going to survive. It's just going to survive just long enough to drill those holes. And I don't really care. All right. Huh, that actually kind of works out. Taping it probably would have been better. Having my punch would probably have been better. But, you know, couldn't quite figure out where my punch had walked off to. Again, that's what happens when you're cleaning and organizing your house. Things just become a mess. So we'll take a smaller drill bit. One of the smallest ones I have. It's been used for drywall. Really need to clean this poor guy up. And we'll punch our pilot, basically a pilot hole into this. All right. Hey now. Yeah, where the punch would have been better at helping me center everything. The drill press would probably be better, but I don't care. If it gets too frustrating, I will take it out to the drill press, but all right. Should probably look for a small drill bit. There we go. Pop through that first hole. Now through the second hole. It probably doesn't help that this is an old drill bit set that's been abused and used for all kinds of different things over the years. And I probably should be using cutting fluid, but you know. All right. And we didn't go through the desk, the spoil board. That's great. So now we have our two holes. Get rid of the template. And that's the one good thing about not using cutting fluid is you don't have to worry about grabbing a rag. Things will just generally get pushed off, fall off real easy. So now we've got our pilot holes. Yeah. Trying to keep everything centered in camera. Well, I should move the camera, but it's the best spot I could find for now. Okay. Put you back. So let's find the right size drill bit for the main shaft. That might be a little too small. That would probably be about right. Oh, this thing's going to be a load of fun when that thing grabs. I might actually want to use the drill press for this. This little cordless has been with me for quite a few years. There you go. Okay. Yes. I'm aware that I'm probably not being the safest I should be with this. But again, if this is something I was going to do more, of in the future, or actually sell these, I would definitely be setting things up right. Like I said, marking jig and using the drill press and fixturing and everything so I don't get hurt. Use the deburring tool, kind of clean this hole up a little bit. Mainly so I don't cut myself, but also so we could test fit the main shaft, at least for now. All right. Okay. So I have this guy, a nice little stepped reamer, great tapered reamer. Hopefully it's big enough. In worst case, I have a step drill bit set, but let's hope that we don't actually have to get that far with this guy. So let's get this nut backed off. So she said, okay. Okay, it's just a little too small, and that's fine. Let's use, oh, there we go. Let's get the reamer in there. I've had this thing for years too. Got it when I was started working with 3D printing. Yeah, there we go. Now we got, I might not be able to have to drill that hole out. Might be able to just kind of use the reamer and kind of, because it also helps kind of clear up the burrs too. Yeah, I'm off camera because I'm doing it over a trash can. No reason to fill my office or my workshop with metal debris. With metal shavings. Alright. Let's see if I can clean. Come on. Don't make me put the deburring tool in there. Alright, I guess I'm gonna have to. Yeah, if you plan on doing any kind of alright, like a glove. A little bigger than it needs to be, but that's fine without like using laser precision or anything. I just wish I had another nut so I could pull this up a little higher, because it, yeah, that guy looks like it's kind of permanently set in there. And then there's, yeah, something else that kind of concerned me for this nut's loose, and I'm going to tighten that up real quick. Don't like that. But before I get any further ahead of myself and do anything else dumb and lose even more of my stuff, let's just put away. So I don't know if you guys have ever heard of something called 5S and 6S now, because they added an extra S. But it's basically an organization methodology and system that you see a lot in factories and other manufacturing environments. I mean, it's really good for anybody, really. Basically, just at the end of the day, it pretty much just means everything has a place, and when you're done with it, you put it in its place. You keep everything clean, everything organized. That way nobody gets hurt. That way you can find your tools at the end of the day. So, yeah, it's a really good system. I'm also kind of disappointed there's no lock washer with this either. I mean, it doesn't really need it with that key there, that oh, it's heavy. And just that sitting in there's warping this guy pretty bad, but that's okay. Don't want to go against the paint. Should have looked for a socket, but that's okay. I can't. All right. Okay. Alright, so that's a little flathead. Not really too impressed with that setup. Who knows? Maybe we'll later down the road we'll kind of come up with a control knob and 3D print it just for something different. Maybe we'll see what we can do. Who knows? But for now, this is going to do all we need. All right. So basically, don't need a spoiler board here anymore. Yeah. All right. Did I not have that in the right? Must not be in the right spot. I put my screwdriver away. All right. Because I don't think it's grab and hold where it's supposed to grab hold of properly. Okay, that's grab and hold properly. All right. Yeah, I was just kind of flipping. All right. That's good. That's good. This stuff away so I don't lose it. I have a bad habit of losing tools. And so my cats don't get any ideas that they can play with it. All right. So that's that cluster out of the way. Now what we're going to do is just we need to kind of figure out how we're going to work all this together, where it's all going to kind of, mainly so we can cut lengths of wire. So with that said, let's grab this guy. Let's grab our front panel meter, make sure it's oriented properly with the volts on top and amps on the bottom. Should just snap, just snap in place. There we go. Let's get our power switch. Because what I'll probably end up doing is just soldering leads to a lot of this stuff. And then just using those levers, those lever locks to... Oh, I need to open you up a little bit. The burring tool. Yeah, burring tools and reamers are really great for 3D printing to do this type of stuff with. They're well worth the investment if you're going to do a lot of 3D printing and design. Go. Beautiful. I think I tested the clearance prior to doing this, but could have just shot myself in the foot. I may not have clearance for the switch, and if that's the case, I'm just gonna go cry in a corner somewhere. We can still wire it up. I'll just have to update the design for the front panel and just print it out and fix it later. But oh no, okay, no, it clears. Okay. Whew. All right. Okay. Oh, it's in there nice and tight. Good. So we got clearance so far, so good. And okay, I mean, it's such good clearance, it just falls out. All right, so that means it also clears the resistor on the inside, which is perfect. Now this little gem, these little gems, these things are going to be interesting. Okay, bye little nut. I don't care. I'll find you later. You're not going to slow me down. I'm not going to slow myself down looking for a stupid nut. Okay. And my watch band wants to come loose. My goodness, what a day I'm having. You'd swear I was falling apart. Okay, so... And this guy's missing a nut too. What in the world's going on here? What in the world? Okay, so we're going to have to obviously solder leads to them. But, so let's kind of think about this. So if the front panel's on, we want to basically, let's just, that much. Let's give ourselves enough to have a service loop on the inside. And yes, with wiring, the longer your wire, the more resistance you have, but this is such an insignificant distance, it shouldn't be a problem. Okay. So at least let's figure this out. Let me go and get these soldered. Oh. At least kind of get them stripped. Oh. Find another set of cutters too. Go over to the soldering work area. Okay. You know what I should find is my board vise. That's because I like holding those little guys a little bit better. Ooh, super close. All right. This poor guy's been used and abused too. I've had this thing for several years. And poor thing's just been abused. And that's what good tools will do for you. That's what they're there for. Not necessarily to be abused, but they'll put up with it. This poor little guy's put up with it. Nice and tight. All right. Pressure on it. All right. Solder on there. All right. Don't know how well focused it's going to be, but you know, that's life. Come on. Come on. Wick into the wire. I distorted it, but that's okay. I guess a pair of pliers will bring it back into shape. That's a good thing about the silicone jacket, is it'll hold up to heat. Which is kind of perfect for inside that box. All right. Yeah, they're soldered good. Let that little puppy cool down. All right. All right. Back to the main workbench. Got those little guys soldered in there. They look beautiful. They should work. Nope. I'm not crying out in pain, so I guess it's good. Just kind of... Nope. Looks like it's nice and solid, so I don't have to trim any of it. So I'll put red here. These feel like M4. So what I'm going to do... Ugh. Yeah. So I'm just kind of... Yeah, wait. Camera mount's a little bit wonky. I feel like M4. A couple of M4 lock washers. I guess that I should have picked up some it's red. Should have picked up some star washers, but you know, hindsight's 2020. Yeah, okay, M4. That's perfect. Not have the point down, but more to the side. Yeah, I probably should have found a socket for this. That's not a problem, though. Hey, now. No, you need to come back over here, buddy. Off to the side. There you go. There you are. All right. Alrighty then. Negative terminal. Boop. Put you in here. Yeah, quality control. Bet you 10 to 1 that's an M4 lock or M4 washer or nut. Yeah, I know I have a socket that would fit this and an actual combination wrench, but you know, it's just easy to grab a pair of adjustables because you never know what you're going to run into. Oh yeah, you got deformed, but that's all right. It'll flatten you out. Oh. Let's see, are you an M4? Yes, you are. Yeah, you were. Yours is probably in the box, the bin somewhere, but. Come on. You know what? That'll work. All right. So then we're going to need to do a little bit more soldering because we're going to need off the power switch. So I almost kind of forgot about that. And we're going to need another set to come off of the input. All right. This wire is relatively low cost on Amazon. That's why I like using it. And just the extra flexibility of the silicone makes it really nice. PVC wire, PVC jack is great for some things, but the flexibility of silicone is just awesome. All right, probably should have soldered that prior to plugging that in, but that's fine. We'll deal with that problem if it becomes one. Gotta figure out what I did with the jack. Problem being so disorganized. Listen here, kids. Don't be like me. Don't grow up and end up like me. A disorganized mess. Oh my goodness. All right. No, I was holding on to the... Oh, hooray. Hooray. Oh, what's been a day? What can I say? These two guys. The iron back on. Use you real quick. Okay, center is positive, and I think, yeah, that one I think is negative. So this power jack. Ugh. Oh, I hate the fact that it's got all that extra wire on there. Yeah, I salvaged that. I reused it. I pulled it out of another project I worked on. Nothing wrong with reusing materials. So, go get a pair of tweezers. One of my junk pairs that I don't care about. I don't want to use a pair of scissors I use for SMT. I mean, I could buy new tweezers. I mean, not scissors, tweezers. Well, you can see that. Gotta get the old wire out of there so it's not a complication. Come on. All right. All right, you look good to me. All right, so let's pull this guy. Now, let's see how much of a pain you want to be. Oh, you want to be a total pain, so you know what? We'll just do this the cheater way. Continue. Continue. Well, that cools down to be a little bit more handleable. Let's get to, or I should say manageable. Let's get the negative tinned. Yeah, it's a little bit bigger wire than that's made to handle, so. Get this guy tinned up. All right. Trim you down a little bit. Okay. Pull back a little bit. I try have to do exaggerated movements with this rig, but hey, that's fine. All right. So solder on here. Okay. Well, come on now. Oh, that's a horrible soldering job. Let's reorient and try to do that better. Yeah, this will do a little bit better. That's gonna get hot real quick though. Perfect. And if I'm not mistaken, it's the... So this is made to be able to be switched. And sometimes I get it wrong. And if I have to rewire it, that way if you have a battery, this can automatically switch between the battery or external power without you having to do anything to it. Really easy to mess that up because I don't have the data sheet on this particular unit offhand. So again, worst case is it's backwards and I have to oh, another fun horrible soldering job. Should have probably done this guy before the positive. Actually, I might want to do it from this side. All right. Wow. Not perfect, but again, it should work. Switch. Don't know why I really even care about positive versus negative. But, you know, I don't know. I like it. You just kind of go this way. Hey, now. Don't be fighting me, a little switch. It's all right. Yep, tweezers. All right, tweezers to grab that, bend it up. We're just going to drown this guy in solder. Know what hit him. Again, another salvaged part. All right, perfect. Let's get this guy off of here. Oh yeah, we also have to tie in some leads for the fan. I just now remembered. Woo! Come on. Come on. There you go. All right. All right. Let's see if we can get this guy in here. He probably won't go in very easily, knowing how things usually work. Oh, surprisingly well. If I was building this device for sale, I would definitely take more time and care and attention to it. That's good. Let that cool down. And I'm not going to switch between the camera. I'm just going to go ahead and cut 2 lengths. Fan. Yeah, I could use smaller wire, but you know what? This is more than enough. I just want to make sure it'll work. Lengths and cut the wire, the fan, and so pin 1 is ground. All right, pin 1 is ground, and pin 2, which on the computer fan connector is actually yellow, that's actually the 12 volts. So this is like many of the other fans. So the black over here is ground. The yellow is actually your 12 volts. And it's marked here pin 1. And then the other two colors, one's your PWM, and then the other one's your tax signal. Get that locked in here. No, just stay with me. Okay. So pretend these guys a little bit. Come on. Oop, there we go. One is ground, so that's your positive. And we can do a real quick test with it prior to actually installing and everything. We can just hook the power supply up to it and make sure. Let's tin this little guy. Let that cool for a minute while I do the negative. All right. And this guy. Yeah, well, I'm doing everything I can to keep everything on camera, but I also have to take into consideration my own safety and not do anything, put things too far out of reach or where I'm going to hurt myself because I'm trying to accommodate a camera view. Camera angles are not more important than my safety, so. Solder on you. Yep. So unfortunately, while I'm doing my best to get it on camera, I don't want to sacrifice my own safety and get hurt just to get a camera shot. Not worth it to me at that point. It's mainly all right. That's actually in there pretty good. Burp. Right, grab you, leave you over here because I may need you more. Who knows? Grab you. Grab all this stuff I just wired up. And go back over here. Oi. All right. So we might push into hour and a half. I'd like to at least get this assembled. Okay, so if we go here, so this power supply out here is basically the what we're testing. That's the the load is the resistor, and then that's the power supply over here. So this one is doing here, so it might be easier to just go ahead and get this guy in here. Let's grab these guys. And 3, they're usually 2.5 millimeter, but the button heads are usually 2. These guys are excessively long. I don't need these guys. Wow. 10 millimeters, way too long. Let's not waste our time. Oh, 6 millimeter will work. Yeah, 6 millimeter will probably be more than enough. Maybe. Does it actually grab into that plastic? No. So we are going to have to go a little bit longer to make sure we grab that plastic. And, you know what? Why are we killing ourselves? Another great tool. All right. Let's see here. Boop. There's my H2. Tell me I don't have an actual 2mm in here. A good thing I do, yeah. Let's go to high torque. And worst case, if we end up having to fight this too much, I'll just grab an M3 tap and we'll just tap the dang holes prior to dropping the screws in. But there we go. Now she's grabbing. Again. Oh, that sounds cool. That's definitely grabbing. But, you know, take it a step further. Let's not mess around here. Let's not play games. So I'm only going to drop 2 screws in one at each corner. Yeah, let's grab that plastic. All right. Oh, yeah. Yep, just 2 screws in there. And then, oh, you know what we need to do? Stop getting ahead of ourselves. And let's start putting this stuff together. All right. Now, excuse the confused look on my face while I try to figure out where the back for that, the nut went for that. Did I leave it in here? No, I did not. Did I, like an idiot, drop it? No, I do not see it. Again, kids don't grow up to be like me. Please be responsible. Oh, there it is. Please be responsible adults. All right, here we go. So you go now. Hello. Oh, nope. Here. Come on, go on. Oh, don't you do this. Just. There you go. Come on now. There you are. All right. Yeah, well, you're kind of facing down with the hay. I mean, it doesn't really matter long at the end of the day. All that matters is you're in. There we go. That's fine. I don't care how perfect it looks. Now we want to figure out if we want to basically pull air in from the sides, basically push air out the back, or pull air in from the back. So what we'll do is we'll have it push out at first, and we'll just see how it performs if we have to flip the fan over at the end of the day to accommodate airflow, or, you know, if it doesn't really work. All right, let's grab a couple of these little guys, these little gems. All right. Why use regular hand tools when you've got things with batteries? I mean, seriously. It's a shame this driver, I can't find it they don't sell it anymore. I've literally had this thing well over a decade. Haven't put new batteries in, new battery in it or anything. It has literally been one of the best cordless screwdrivers I've ever owned, hands down. Hands down. Oh, that screw's gone. No, seriously, I'll find all these screws after the video and get them off the floor. I don't need my cats finding them and turning them into toys or eating them. It's just, I don't want to waste time looking for a screw that I could just find afterwards. Oy. Yeah, Craftsman stopped selling this thing. It's a shame because this is like one of the best ones I've ever had. I give it hands down. So those are plastic thread forming screws. All right, so in this guy, you know what we can do real quick is we can take the power adapter. We can test two things at once. So plug it in. Worshippers. Worshippers. Not the cleanest, not the prettiest. Serves a purpose. So this will test to make sure we have all our wiring up properly. And no, I don't. Chances are that I'm soldered onto the wrong tab here. So let's go take it back over. I'm not going to bring you with me. This will only take like 2 seconds to solder that to the other tab. Literally. Oh, the most time I have to waste is the damn soldering iron heat up. So I bet you I got that wrong. I wish I would have had the data sheet, the diagram for these power connectors. I'll dig all that up before I create the wiring diagram for there we go. Boop. All right. Quickly redone, and with any luck, the fan will spin. There we go. So Noctua, so it is literally quiet. Okay. Yeah. Oh yeah. Yeah. So the only reason I might just keep this fan in here because of how quiet it is. I mean, literally. So quiet the mic doesn't even pick it up. That's all right. So we proved that our polarities are right. The connector is working. The fan's wired up correctly. Get you out of here. So, because I don't want to break anything, I'm not going to flip that over and hold it down. Again, just a couple of screws to hold the panel on so it's not flopping all over the place on us. Besides, in a way, this is kind of like a prototype anyway of the test fixture. Okay, perfect. Perfect, perfect, perfect. Now we have this guy. So this is the power for the electronics. And then we have the fan. So we have the switch, the fan, and the power to the electronics. So we're going to need a 2, 3. Yeah. Wow, I haven't even used these yet. I've used the doubles, but not the triples or the quadruples yet. Or the, what are those? 5s, yeah. No, 5s. Okay. These are perfect for low current applications. Love it. I love when people come to my stream just to advertise. All right, perfect. Beautiful. Probably grabbed too many. I only needed 2. I don't know why I grabbed 3. But hey, you know, that's fine. That's life. So, we have fan negative. No, wait a minute. Fan, that guy. No, actually, I will need the bigger ones. And I will need a double. My goodness. My brain's just not with it today. So we have the positive coming in from the power. Let's logically follow this and do this right. And that comes down to the switch. All right. Okay, those guys do grab pretty good. So idealistically, what I'd probably end up doing if this works and it looks good, I've got some little zip tie holders that have the self-adhesive padding on the bottom. I just strap them down and tie all this stuff to the bottom with that. So we have the negative off the switch. So we have, let's see here. Okay, this is for the load. We don't even concern ourselves with that for the minute. Negative off the switch, which isn't technically negative, but so that's technically positive. It would come to the fan and the electronics, so that would definitely be twofer. No. 3-way. My bad. Should have made the switch like both red, but you know. And I'll clarify and fix all that documentation and drawings and stuff. Yeah, these guys are nice. Alright, we're going to need to pull a little bit more off of these guys. Oh, let's kind of reduce your strength there, fella. I might have to go grab a regular set of wire, Mr. Person. Okay. Okay, so positive, negative. So based off of that, this is the power supply that just feeds the electronic package. Don't know if that'll actually grab a hold of this, but we'll find out. Actually, it does. Ow. Some good clippy action. All right. So now we have the negative. The negative, which comes in from here. And all right. Yeah. And And then the negative from this fella just drops right in here. Okay. So that should be the core wiring of the electronic package. And I'm just going to go and get the... There we go. That's tied in. So then the yellow becomes the voltage tap to measure the voltage. So the current is actually measured between these two, the red and the black, via an internal shunt resistor, basically. It's just measuring the voltage across the resistor, calculating it. And then it's using this because it needs to know the voltage to calculate current based off, it just needs to know all these details. Okay, so basically you have, off the red, your positive coming in. So it comes in off of here. Before I go too much further, let's plug you in and drop stuff. Okay, all right. So, switch went on. Electronics came on. You're going to just see it because of the way it's thinking through. The fan is running. Beautiful, beautiful. Okay. So, our power positive comes in through here, which you get tied to this guy. All right, get tied to this guy. And then these guys are going to get tied to the load resistor. So we're going to, again, like I said, anything I drop, because I'm such a clumsy fool, I'll pick up so my cats don't get hurt, but after the video. So I've got these little fellas right here. All right. These guys. So these guys are what I'm going to do to tie, what I'm going to use to tie to the resistor. Let's make sure M5 will pass. Oh, yes, it does. Perfect. All right. So we have that. Let me grab my crimp tool. Don't need a pair of pliers at the minute. I just need my crimping tool for those terminals. Yeah, it's amazing how well prepared I am. Wait a minute. Those aren't the right terminals. Of course they're not. Of course they're not. I just switched out to do something else. And this tool's another one I bought off of Amazon. Here we go. This looks like, yeah. This looks like the one I've been using. Comes with all kinds of different dies to do your crimpings. Relatively quick change. Just pull out a screw, pull out the die. And you can do all different sorts of terminals, insulated, non-insulated. Flags, the ones that come off to the right angle versus straight out. All right. So I like it. Go. Quick change. There we go. Again, I'm super prepared, aren't I? Yeah, I like this guy because really solid crimping. And the ratcheting style really helps a lot. Ooh. All right, so we got that guy crimped in. So that takes care of, so your power supply coming in through here. Here, tying in here. So that's going to go to the resistor. And then off of the resistor, it needs to come to to the positive. Give me a little bit more bite. All right, a little bit more bite, I see. Okay, and do the same for the negative. Might as well. There we go. So off of the other side, the wiper basically will come into here on the positive side. I think. All right, so this will be off of the wiper of the resistor. And then this guy needs to be tied to the negative terminal coming off of here. And what do I have? Oh, do I have any? Oh, I do. I have a butt splice connector. Probably should be using something more undoable, but since I can disconnect things on the inside, it's fine. I can undo things. That's that guy. Yep. All right. All right. Oh, you little sneaky beaky. Yeah, that's probably the last one I have too, is the butt connector. Oh, you little bugger. I bet you I can't wait. Force this guy back in there. Oh, wait a minute. Oh, can I? Okay, let's find out. Oh, no. Okay, fine. Let's figure out how we're going to solve this problem. These guys are too small. They might work if I crimp them extra. Not for 18 gauge, but sometimes it'll work. Let's see what I did wrong. Sometimes you can just force these little guys to use the wrong die, but that's fine. When you're in a pinch, anything will work. There we go. Come on now. Don't fail me this time, buddy. There we go. All right. Tie you into the front panel. Okay. So now we need to get tied to the resistor. This is going to be the pain in the butt. So we're going to, let's see here. We're here on the wiper. Oh, wow. I wish that was a little bit longer, but it's not. Okay. Okay, so let's just say that's on the wiper, because technically it doesn't really matter. All right. Nothing like trying to work in little spaces like this. So we'll kind of want to think about our logic on this. Maybe if I go this way, I can. Okay, much better. All right, this guy. Maybe this guy would be a little bit easier to get up in there. Hello. Oh, well, wait a minute here. Oh, that'll work for now. That'll get that guy in there. Derp. Okay. Where'd that millimeter go? So we want to kind of think about our logic here, how we want it to go. So we're sitting here. Seriously, I still left you plugged in? Wow. So if we want it to clockwise increase our resistance, which will decrease our current. All right, so for wiper there. So we'll want to put it here. So basically maximum resistance over here. Or do we want to think of it reverse, increase our current by going up, by reducing the resistance. So let's start with the putting it over here first, basically increasing our resistance value. And let's find the other terminal. Oh, well, that might be doable too. All right. Okay, that makes life a little bit easier. Crap. I guess that would be this one over here. Oh. See. Decrease. Resistance. Yeah. Yep. Hello. So we have to be mindful then that we could actually bring the resistance so low that we actually short it out. But, you know, nothing says maximum current like a direct short between this. All right, so let's kind of pull this guy back a little bit. Wires. That's that. Here's the all right. All right. Kind of in the middle. Don't know if we can really measure the resistance through the enclosure. I could just foresee my world exploding on me and everything just flying to the ground. So let's avoid that. Well, shall we? So what we're going to do is get this in here. Okay. Do feel airflow. So even though you really can't hear it, you know it's moving. I can feel it. So what we're going to do is do something absolutely crazy and stupid. Absolutely crazy and stupid. I mean, we're going to actually see if we get current to this. Don't have double banana plugs, I don't think, but I do think I have bananas connected to no, alligator clips connected. These guys. These are clips to... I think I can make that work. All right. So... okay, we're roughly halfway. Oh yeah, these are... binding post style, so... all right. Well, let's turn the output on and okay. All right. Move these guys so I don't. All right. It's not too far off. So I don't know how well you can see that. My God. Let's turn this off. Let's see if the light interference is calling a problem. All right. So it's saying about 23.3 volts at like 710 milliamps. On the power supply, it's showing 23.9 volts with a current pull of around 700 milliamps. And that doesn't help. Okay, so it's not that far off. So as we go clockwise, let's see if we can get this better. All right. So as we go clockwise, our current drops. So 23.9, 471 milliamps, 470 milliamps here. So that's our resistance up. Slowly bring it down. Must have a piece of wire stuck in my finger. Pulling 1 amp. Again, if I'm not too careful, we're going to hit the end of the wiper. What I might do is I might design and 3D print something that kind of clip on there or something to act as a stop to keep it from hitting the end of the wiper, because what it'll do is short out and the overcurrent protection will kick on the power supply, which would be fine. $23 volts. So mind you, it might also be reading because it's actually loaded. We're at 1.5 amps. Push this up a little bit. There's almost no in between. So according to the box, we are pulling 2.4 amps at 22.8 volts. Again, the voltage might be because it's actually being loaded now. We're drawing current. And then the desktop power supply is 23.9 volts at 2.34. So they're not perfectly in line. I'm sure there's a calibration method for this. But proof of principle, proof of concept, it actually works. So what I'll do is I'll get the rest of the screws in here. And hopefully the next viewing, the next stream, let's see, what is today, Wednesday, which would be Friday, we can, like I said, I need to work on organizing my workbench. So which will be Friday, we can start doing some of the deep testing.
Items by frequency of use and
What in the world are you doing, Gemini? Jesus Christ. All right. So what we're going to do is, so we don't need to watch that anymore. Let's go back to y'all. So what I'll do is, like I said, I'll tidy the box back up, get everything wired, screwed together, cleaned up a little bit. And then hopefully Friday stream, we'll start doing the current loading tests on the board for the power supply, so we can draw current through the power supply and check for ripple and all that fun stuff. And maybe load down the stepper motor driver. I'll just run it through where it's like trying to drive and just trying to actually push, 2.5 amps through this box. It'll take some dialing in, but basically we're just going to drive the stepper motor and have it basically cry while it's trying to actually drive the resistor in here. But everything, as far as I can tell, is a success. This box does work. Again, it would be nice if I could calibrate that ammeter, that panel meter. Maybe I can find a better one in the future, but for now it'll do, it'll work, and it's perfect. So thank you for sticking with me through this build. I know, kind of hectic, helter-skelter. I'm not as organized as I probably should be. I need to get my workbench cleared off, my workshop cleaned up a little bit better. But again, life just keeps me busy with my job and everything else going on. So thank you. Have a great evening, and we'll catch you on Friday, and maybe we'll pop a board or something. Who knows? We'll see what happens. But have a great one. Take care.